next let's move on to the next problem. Yes, which is this. Okay, so the question goes like this. Signum function, another way to we know that signum function is how much here? That is 1 when x is greater than 1, 0 when x equal to 0, it is minus 1 when x is less than when it's 0, 0. Correct. So this is the way how we defined the signum function. Another way to define is this. This will give you the same answer. Okay. So now the question is we have to find the Fourier coefficients for which function? Signum of cos t. Okay, so let us write down again what is signum of x. Signum of x is 1 when x is greater than 0, 0 when x equal to 0, minus 1 when x is less than 0. Okay, that we already know. So now let us write what is signum of cos t. So signum of cos t. So what is signum of cos t here? Wherever there is x, we have to replace with cos t. So here it is 1 when x should be replaced with cos t. When cos t is greater than 0, 0 when cos t equal to 0, it is minus 1 when cos t is less than 0. Okay, so what is cos t? Let us try to plot that. Okay, so this is our cos t. So it is a sinusoidal, cosinusoidal signal. The plot will look like this. Correct. So this is our cos t. Okay, so what are the limits? So this is 0. This should be pi by 2. Here you have pi, and this is 3 pi by 2. And here you have 2 pi, and this process continues. So in negative time also this would be minus pi by 2. This is minus pi, so this is minus 3 pi by 2, this is minus 2 pi, and so on. So what is this function here? This is our cos t. Okay, but let us try to plot signum of cos t below this. So what is signum of cos t? What is it we have said? So we are plotting signum of cos t. Okay. Yes, so how does the plot of signum of cos t look? Yes, so signum of cos t is what? When cos t is greater than 0, it should be 1. So from minus pi by 2 plus pi by 2, cos t is greater than 0, and hence signum of cos t should be how much? It should be 1. From where to where? From minus pi by 2 to plus pi by 2. So that fellow should be 1. Okay, then so from pi by 2 to plus 3 pi by 2, so this is cos t is how much? Minus 1. So when cos t is less than 0, correct, when cos t is less than 0, signum of cos t would be minus 1. So from minus pi by 2 to plus 3 pi by 2, this fellow is minus 1. Then again from 3 pi by 2 to plus 5 pi by 2, that fellow is plus 1, and this continues. Okay, and similarly for negative time also what will happen? So from minus pi by 2 to minus 3 pi by 2, that fellow is how much? That fellow is minus 1, and after that that fellow is plus 1, and so on. Okay, yes, so and this process continues. So this is minus pi by 2, 0, pi by 2, pi plus 3 pi by 2, and so on. So clearly what is the period of this signal here? Period of this signal is 2 pi. And what are the extra informations you get? Okay, so this implies we are talking about signum of cos t. Period is 2 pi, that is fine. Then what is extra information you get? This fellow is even, correct? So this fellow is even, and one more thing, this fellow is odd half wave symmetric. Why? You shift the signal to the left by t by 2, which is pi, and then multiply with minus 1, you get back the signal. Okay, so because this fellow is even and odd half wave symmetric, so what will happen? What will happen here? So because it is even, what will happen? bk equal to 0, right? So bk equal to 0 and a naught and a case exist. Okay, that is because it is even, and because it is odd half wave symmetric, what will happen? Only odd harmonics exist. So this implies a naught is 0 and only a1, a3 and so on only exist. So means what? We will have cosine terms, and in that cosine terms we will have only odd component. So that would be the Fourier series components in signum of cos t. Now let us look at the question. Okay, so we know that now, just now we derived that signum of cos t is what? It is a periodic rectangular wave which is even and odd half wave symmetric. Now let us choose the right choice. Only sine terms exist with all harmonics. This is wrong. Okay, only cosine terms with all harmonics. This is also wrong. Only sine terms with even numbered harmonics. That is also wrong. Only cosine terms with odd harmonics, and this is right. So that is what we have seen, right? What is that we have got? Only cosine a1, a3 and so on, they are cosine terms, and only who will exist? Only odd coefficients exist, and hence what is the right choice here? Right choice is only cosine terms with odd harmonics. Okay.